Now let's take a look at the classical poker hand problem. These are interesting problems. I would encourage you to definitely pause the video for every new problem and give a try first. If you are able to do all of them, I would rate your the ability to apply the multiplication rule and combination I'll rate your skill at a pretty proficient level. All right, let's begin with the first one. So we have 52 cards in a deck of poker card without jokers. Each suit contains 13 cards: ace, 2 to 10, jack, queen, queen, king, right? So now let's look at the first problem. 5 card. What is? Let's find the distinct number of each of the following. Say the first one is 5 card poker hands. Any arbitrary. How many different ways to get 5 card poker hands? This should be pretty straightforward. So this is, we have 52 cards. We just choose 5. How many are there, right? How many possible ways of doing that? This is the answer. I'll leave out the calculation so that you can do a little calculation by yourself. The second one is a royal flush. And what is a royal flush? Royal flush is a 10, jack, queen, king, ace. You have this order of the same suit. Now how many are there? We have 4 different suits, right? So therefore there were only 4 of those. Really not much counting here. We just use common sense here. A straight flush. What is a straight flush? 5 consecutive dominations of the same suit, but cannot be royal flush. So for instance, if you have diamond, ace, 2, 3, 4, 5. So in diamond, then this will be considered as a straight flush. Now, because it has to have a 5 consecutive dominations, so here are possible the combinations. It will be that when ace is low, the ace, 2, 3, 4, 5. This is the first one that you can have. You can have 4 different suits, right? And the second one you could have is like starting with 2, starting with 2, 2, 3, 4, 5, 6, and so on and so forth. And the very last one that you can have is, you cannot have 10, jack, queen, king, ace, because that will be considered royal flush, so we do not consider that. Actually, the last one that you can have is 9, starting with 9. Okay, so that's considered a straight flush, and ace can be low or high. Now, because we have only that many possibilities, so let's say 9 choose 1. Why 9 choose 1? Because we have only these 9 possibilities. Just begin with a 9, right? So for any one that you choose, there were only 4 different suits. So just times 4. 4 choose 1, which is 9 times 4. That's 36. Or you can just think about, for each one there were 4 suits, and there were total 9 possible straight flush. So 4 times 9, which is 36. 4 of a kind, that means 4 cards are of the same domination, and the very last one can be anyone. Now this one will be, my step 1 is to choose one domination from the 13 dominations, right? And that will be the 4 of a kind. And for the value that chosen, all those 4 numbers should be chosen. So all 4 those cards should be chosen. If so therefore 4 choose 4. Sometimes this can be skipped. And now for the rest, for the last card, the very last one, and then because four cards are gone from the 52, so you're left with 48 cards, and that any one from the 48 remaining cards can be chosen. So this is how this is the four of a kind. So which is let's just quickly do this algebra. This is going to be 13 times 48. 13 times 48. Okay. And what is 13 times 48? Let's do a quick algebra here. 14 times 13, I'm sorry, 13 times 48, which is 624, right? Now let's take a look at full house. And what is a full house? Full house is 3 cards are of the same domination, and 2 cards are of another domination. So for instance, if you have 3 A's and then the other 2 like 2 3's, that will be considered as a full house. Okay. Now to find the full house, first step, I'm gonna 13 choose 1. That means I'll select one of the domination for my 3 of a kind. I mean 3 for the 3 cards that has the same domination. So pick one domination, and then because we have 4 cards of this value of this domination, and we are going to choose 3 cards out of the 4 cards of this domination, right? So that's the step 1. That's getting the 3 cards. Step 2, I have to pick another value from the rest of the 12 dominations, and then pick one. And again, we have to have 2 cards of another domination, so we have to choose 2 cards from the 4 cards of the domination chosen. So this will be the how many possible full houses are there. Okay. Now let's take a look at flush. Okay. What is a flush? Flush is 5 cards of the same suit. 5 cards of the same suit, and of course we have to exclude the royal flush, 5 cards of the same suit, and the straight flush. So we have to find all the 5 cards of the same suit, when we have to take away the royal flush and straight flush to get the correct count of how many flushes there. So therefore I'll say first of all, we are gonna select a value. Okay. So step 1. Step 1. Select 5 different values, 5 different dominations from the 13 available, 5 cards, right? That of the same suit. So we have to have 5 domination, and from each one of those dominations, you have to pick 1 card from it, right? I mean, pick a suit. We have 4 different suits, so pick 1 suit. Okay, if you have club, then that will be one of those. So just out of the 4 different suits, pick 1, and out of the 13 dominations, we pick 5 dominations. So these 2 steps will give us all the possible flush hands there. However, we just mentioned that we have to exclude the royal flush, which is 4, so we are going to minus 4. And we also have to exclude straight flush, so minus 36. So that will give us the correct count for the flush. Okay, let's take a look at the straight. And what is a straight? Straight is 5 consecutive dominations, however, not all the same suit. Otherwise, if you have all the same suits, that will be so-called a straight flush, right? Straight flush. So this should exclude the straight flush. Now, we also, we also need to exclude the royal flush, and so one way to do that is think about the straight. You have these possibilities. It starts with ace, 2, 3, 4, 5. The second possibility will be 2, 3, 4, 5, 6, and so on and so forth. And the very last one is going to be because we want to exclude the royal flush, So you can say the last one will be 9, 10, Jack, Queen, King, and you stop here because the next one will be the royal flush. Let me think about this guy. Actually, I'm sorry. I think the next we should continue. The very last one can be 10, Jack, Queen, King, Ace. As long as they're not the same suit, that will be still a straight. Okay, so actually this is the last possible straight that can have. So there were 10 of those. So now let's take a look at. So I'm gonna pick one of those pick one from these 10. Step 1, choose one of those. So 10, choose one. And step 2, because we have for each one we have 5 cards, right? So therefore we have to pick one card from each of those 5 consecutive dominations. So I have to do that 4, choose 1, 5 times. 5 times. For instance, suppose this is chosen, then this is like the value 10. So we have to pick one suit from the 4 suits for number 10 and pick one suit from the 4 suits for Jack, and so on and so forth. Okay, so this is my second step. Now, however, when you do that, it's possible that you get a straight flush, and it's possible you also get the royal flush, especially for the very last one, right? So therefore, we have to minus those royal flush, which is 4, and minus the straight flush, these possibilities. Okay, so therefore, this would be the correct count for the straight. Now, 3 of a kind. That means 3 cards are of the same domination, and 2 other cards are of different dominations. Now, this is where some possible mistake that can happen. I have often seen students making one kind of mistake here, which will lead to overcount. So I'm gonna first tell you what the correct count is, and then I'm going to share with you a possible mistake students sometimes make. Okay, so the correct way to do that is, we have to first find pick a domination for the 3 cards, right? So therefore I have 13, choose one, pick one domination, and from this domination we have to pick 3 cards out of it to form these 3. Second step, we still have 2 other different cards, and they are different dominations. So therefore, I have to pick 12 from the rest 12 remaining 12 dominations. I'm gonna pick 2 dominations out of it, and then for each domination, I'll pick 1 card, right? One suit. Okay. So therefore, this guarantee that this is a different card, the last 2 cards will have 2 different dominations. So this is the correct way to count. Now, sometimes this is, so now I'm going to say a possible error here. So some students may think, okay, the first step, I'll pick 1 domination for my 3 cards of the same domination. So 13 choose 1, and then 4 suits, choose 3, right? And second step, repeat the same. I'm gonna, from the rest of the 12, I'll pick 1 and then 4 choose 1 because I need 2 different dominations. So I'm gonna pick 1 for the first, basically there were 3 cards already. So this is the 4th one. So they think that the 4th one will be from one of the domination from the remaining 12 dominations, and then pick 1 card out of the 4 card, and then finish by, so for the very last one you have only 11 dominations now, so pick 1 of it out of it and then times by 4 choose 1. Now the problem is this will lead to overcount. Okay, for instance, suppose in this case, suppose ace is chosen, so 3 aces will be for the 3 cards that have the same domination. Now this one can be, say, suppose 2 is chosen, okay, a diamond 2, suppose. And now the next one is a 3 is chosen, okay, a club, okay, a club 3. Now obviously, suppose in this counting, this will be considered as different results. The way using the multiplication rule here, this is actually treated as different from that. However, they are actually the same results. They should be considered as the same poker hand. So therefore, when I do 12 choose 2, so when we choose 2 dominations, we consider order doesn't matter. So here the order really doesn't matter. When you do this step, you will treat the order matters. So that's one possible error that students sometimes make. Well, I okay, so just be a little careful there. Okay, I'm gonna continue. Now 2 pairs. So this is actually some students make similar mistake when they find the possible number of poker hands for 2 pairs. So the correct way, by the way, 2 pairs means 2 same domination, and 2 cards another domination, okay, but the same domination, okay. And then for the very last one, the third domination, okay. So therefore, there should be 3 different dominations. Now, how do we correctly count that? So first of all, I want to make sure the order doesn't matter, okay. So for these 2 different dominations, for the 2 pairs, I'll say 13 choose 2. Okay, I need 2 dominations for the 2 pairs, and for each domination, I'll pick 2 cards out of that domination. So times 4 choose 2 times 4 choose 2, and then for the very last one, the third one, it has to come out from the so 11 choose 1. There were 11 domination left, so pick 1 from there, and then once that domination is chosen, just pick 1 card out of the 4 available, right? So this is the correct way to do that. So a possible mistake is some people say, okay, the first one out 13 choose 1, 4 choose 2. For the second one, 12 choose 1, 4 choose 2. And then for the very last one, 11 choose 1, 4 choose 1. This will not be correct because when you do that, you consider the order matters, but the order really doesn't matter. All right, 1 pair, that means 2 the same domination, right? Same domination. And for the other 3 cards, they have different domination. Okay, so therefore, how do we choose this correctly? So first of all, I'll pick 1 domination for these 2 cards. So 13, choose 1, and then 4 choose 2. choose 2 cards from the 4 cards of the same domination. Now for those 3 cards, this is where you have to be careful. Okay, so for those 3 cards, I have 12 dominations left. I'll pick 3 out of those. Okay, and then for each one, I'll choose 1 card. This is the correct way to count 1 pair. The very last one is no pairs. No pairs means all the numbers, they are completely different. All the dominations, they are different. And they cannot be straight. They cannot be straight. They cannot be a straight flush. And they cannot be royal flush, right? They cannot be the same, they cannot be flush. They cannot be flush, I'm sorry. They cannot be flush. Okay, so now this is how I would do. So no pairs, that means 5 different dominations. And make sure that that they're not straight, okay? Not straight. Otherwise, we'll call it straight, right? So not straight. Now that means I have to choose 5 different dominations in my step 1. However, I want to avoid that they're not straight. And how many straights that we possibly could have? There were 10 possible, that you have 10 possible straight. So therefore, I have to minus the 10. Minus the 10. That's how many ways you can get 5 different dominations, but at the same time, they're not straight. Okay, so this is the step 1. Step 2, you have 5 cards, 5 dominations. Now each one you have to pick 1, right? You have to pick 1. So therefore, I have each domination. I'll pick 1. Pick 1 card out of the 4. So there were 5. 4 choose 1 multiplied together. Now you also want to make sure that they cannot be the same suits, right? So if they are the same suits, we call it a flush. So we do not want the flush. So in the second step, you want to make sure they're not the same color, not the same suit. So minus the 4, okay? This means not the same suit. So you have to subtract the possibility of the same suit. So therefore, this times this will give you how many no pairs. Okay, all right. This is a very classical problem. I feel like if you are able to do all this problem, you have a very good understanding on this type of counting problem.